Good morning to you and welcome to British Airways to Concorde and our unique supersonic operation. Today from London's Heathrow to New York's John F. Kennedy.
First supersonic commercial flight commenced by Concorde on March 2, 1969. The aircraft was the joint production of two manufacturers, British Aircraft Corporation and Sud Aviation from France. It could reach the cruising speed of 2,179 km per hour, which is more than twice of the speed of sound. The aircraft could travel between London and New York in just 3 hours. The first supersonic flight in service for the Concorde started on January 21, 1976, and British Airways and Air France were the only airlines that used it in their transoceanic flights. Concorde had its last flight in service in October 2003 after 27 years of supersonic flights. There were a few reasons that Concorde and dreams of having supersonic flights as a norm ceased to exist. One of those reasons was that Concorde flights were not economic by any means. The development costs of Concorde were so high that the total operation of the aircraft did not cover its building costs. Secondly, the environmental factors played an important role in stopping Concorde's supersonic flights. The carbon footprint that the aircraft released into the atmosphere, flying 60,000 feet above the Earth, could have had irreversible damage to the environment. Moreover, the Air France Concorde fatal crash on 25 July 2000, which led to death of 109 people on board and 4 others on the ground, was a severe hit on Concorde's reputation. All of these reasons combined with the staggering maintenance costs caused the huge slump in Concorde supersonic flights, resulted to British Airways and Air France to become unanimous to put an end to Concorde supersonic flights. However, in recent years, a handful of startup companies want to bring back the supersonic flights to life. A couple of them want to cater to rich people by manufacturing supersonic private jets. But there is one startup company from Denver, Colorado, which is going to build a supersonic commercial airplane which targets the general public and people whom dream of flying with a supersonic aircraft. The company is Boom, and its founder and CEO Blake Scholl has strong ambitions and solid technical and technological achievements so far to resuscitate and revive a supersonic aircraft which resembles Concorde but superior technologically and economically. Boom Supersonic was founded in 2014 for the purpose of making supersonic flights viable and feasible in the near future. Mr. Scholl's dream was to bring back something similar to Concorde, which it would use the Concorde's overall design as a basis for the company's future supersonic aircrafts. The airplane will have 55 to 75 seats and will be flying at a cruise speed of 2,335 km per hour, which is more than twice of the speed of sound. The price to fly with the airplane will be the same as a business class flight fare. According to the founder of Boom, with limiting seats to around 55 and charging passengers business class fares, all seats will be filled and the supersonic flight is going to be economically feasible by flying to more than hundreds of destinations. However, some technical and environmental aspects should be addressed by the company before making supersonic aircraft a reality. To make sure that these aspects will be dealt with accordingly, the Boom will fly an aircraft with the size of a fighter jet. The airplane is called XB-1, also known as Baby Boom. The XB-1 is the prototype for the main 55-seater aircraft, which will be called Overture. XB-1 will have same speed as Overture, and it is going to be tested in mid-2020. Scholl states that the Baby Boom is being tested in every technical aspect to make sure that everything will work perfectly on Overture. He and his team so far have done more than 350 aerodynamic design iterations, and in addition to this, more than 1,000 material tests have been carried out to make sure key structural components such as spars, ribs, tails, joints, and mechanisms such as actuators work properly and flawlessly. Moreover, the XB-1 passed multiple tests in the wind tunnels. The first test was done to get calibration data for the tunnel and the scale model. The subsequent test was done to confirm the calibration data. The third tunnel test examined how the XB-1 will behave in the air to make sure that the final design would be in accordance with aviation safety rules and also expectations from the company. The last test result, which was done in 2018, came out successful. The last wind tunnel test analyzed the performance of engine inlets. Due to the fact that the supersonic flights have the speed twice of the speed of sound, the friction between air and the aircraft increases drastically. To clarify, the speed of Mach 2, which is about 2,450 km per hour, would cause the nose and leading edges of airplane to reach temperature of about 120 degrees Celsius. In case of XB-1, the speed of Mach 2.2 will cause the aircraft to heat up to 152 degrees Celsius and even higher based on the environment's temperature. The high temperatures will damage the engine core, but Boom came up with a great idea to solve this frightening and dangerous problem. The company designed engine inlets that reduce the incoming air before it reaches the engine core. The supersonic airflow speed will be slowed and then compressed to the speed about half the speed of sound. In addition to this, the inlet needs to provide uniform airflow which keeps the engine cool and prevent them from being damaged by the air that is choked. This means airflow density due to compression increases to the point where its velocity slows down to a significant level. This does not happen in subsonic speeds because air goes directly into the engine. However, to prevent this in supersonic airplane, a complicated compression inducting system is required for supersonic speeds to inject uniform airflow into the engines. Boom's engineers successfully came out all of the tests about previously mentioned obstacles. All tests were done in wind tunnels at a speed of Mach 2.2, which included all modes of flight from takeoff, ascent, and cruise to overspeed conditions. In addition to these tests, the XB-1 and Overture both were tested for fuselage strength. The fuselage of the Boom aircrafts is made of carbon fiber with some metallics including titanium components for preventing aircraft fuselage from overheating. To examine fuselage strength, numerous tests were conducted in different altitudes and environments. The effect of extreme cold on the aircraft's body was tested at subsonic altitude of 30,000 feet or 9 kilometers, and also the effect of excessive heat at supersonic altitude of 60,000 feet or 18 kilometers above the Earth was examined. The Overture will be the Boom's first commercial supersonic aircraft. According to Blake Scholl, the first test flight for the Overture is scheduled to take place in 2025. This will sign the first commercial supersonic flight 22 years after retirement of Concorde. Boom is positive that its supersonic flight will be flying as planned. As of May 2019, Boom raised more than $140 million from investors, and this amount of capital assured the company about expanding its vision and mission. According to Mr. Scholl, the most important factor for Concorde being discharged was regarding to its fuel efficiency. He states that by reducing the fuel consumption to 30% lower than Concorde, the supersonic flight would become viable. He thinks that making the Overture 30% fuel efficient is certainly possible. He discussed this idea with experts in aerospace industry, and they agreed that this milestone is achievable. This was the main reason he started the company to bring back supersonic flights. The Overture will have 3 engines, one under each wing and one on the rear of the aircraft. According to Blake Scholl, the engines are more probably going to be built by General Electric, and these engines do not require afterburners. Overture will use biofuel as an alternative fuel type, which is considered as a clean energy. Boom is now partnering with a company called Prometheus Fuels, which makes zero net carbon fuels by harnessing carbon dioxide that is in atmosphere. Also, the special design of engine inlets, which as previously mentioned, decreases the speed of wind at supersonic speeds, would reduce fuel consumption significantly to a level of contemporary subsonic airplanes. To reduce engine noise, Overture will fly at subsonic speed over land. This means that there will be no sonic boom occurring when airplane flies over cities and densely populated areas. However, the aircraft switches into supersonic speed when it cruises over ocean at 60,000 feet altitude. These criteria would show enough justification for environmentalists and opponents of supersonic airplanes, and would subside concerns and doubts regarding the detrimental effects of supersonic flights on the environment. Overture flights will mainly focus on 500 transoceanic routes such as London to New York and San Francisco to Tokyo. This means that a businessman can fly from New York to London in the morning, have his meeting during the day in London, and come back to his home in New York before the midnight, says Mr. Scholl. This only for the price of $2,500, which equals with a business class fare for a long-haul flight, but for half the time. According to him, this flight will take just 3 hours and 15 minutes. He also adds that Overture will have comfortable enough seats that matches the comfort level you would find in business class of commercial airlines. So far, 2 major airline companies pre-ordered Overture aircraft, which are Japan Airlines and Virgin Group. Overture price tag is $200 million, and Japan Airlines pre-ordered 20 of it with the price of $4 billion. Virgin Group has ordered 10 aircrafts for the price of $2 billion, which makes the total of $6 billion worth of pre-orders. Moreover, Japan Airlines cooperates with Boom to build and create in-flight experience of Overture, and also to plan suitable routes. One of these flight plans and experiences will be a faster flight time, more specifically between Tokyo and San Francisco. Reducing the flight time between 2 cities to 5 hours and a half would increase flexibility and empower the customers of Japan Airlines. The massive amount of pre-orders is an affirmation for Boom to rolling forward more deals with these airlines, and also a new outlook for more pre-orders and contract with other big airlines. Boom Supersonics estimates that during the years 2025 to to 2035, between 1,000 to 2,000 Overture airplanes will be ordered by different airlines, which amount to $265 billion. Could these all be a new beginning for supersonic flights? We should wait and see. But one thing is certain: if all of the estimations, numbers and figures given by Boom Supersonics come out as accurate, then we can be assured that supersonic flights will entirely change the concept of travel as we know it today. People can travel faster, more efficient in aircrafts that will be economically competitive with current airplanes used in airlines. These advantages can pave the way for supersonic flights to become more popular, and maybe sometime in the future, most of the long-haul flights would be done by supersonic aircrafts.